Hi, in this video we're going to take a look at the graph of the basic cosine function. So we're going to do the same thing that we do with a lot of functions. We're going to make a table of values and then we are going to plot them and see what it's going to look like. So let's go ahead and start. I already have it pre-filled with x values. So cosine of 0 is 1. I hope you already know these values. Cosine pi over 6 square root of 3 over 2. Pi over 4 is going to give you square root of 2 over 2. This is 1/2. Cosine of pi over 2 is 0. Cosine of 3 pi over 2 is negative 1/2. Cosine of 3 pi over 4 is negative square root of 2 over 2. This one is going to give you negative square root of 3 over 2 for 5 pi over 6. For pi it's negative 1. For 7 pi over 6 you're going to get negative square root of 3 over 2. For 5 pi over 4 negative square root of 2 over 2. For 4 pi over 3 it's going to give you negative half. For 3 pi over 2 is 0, then 1/2, then square root of 2 over 2, square root of 3 over 2. For 2 pi it's going to be 1. This completes a full revolution and then it's going to start all over again. Square root of 3 over 2. As remember, 2 pi we completed a full circle. So for each one let's write decimal approximation so we can plot them easier. So that's 1 obviously, that's 0.87, that's 0.71, that's 0.5, that's 0, that's negative 0.5. Here we're going to have negative 0.71, negative 0.87, negative 1, negative 0.87, negative 0.71, negative 0.5, 0, 0.5, 0.71, 0.87, 1, and 0.87. Alright, so what we're going to do now is we're going to use these values and we're going to plot the graph. Okay. So we are going to, I just have to make one correction. That's going to be 0.5, that's going to be 1. That's going to be negative 0.5, that's going to be negative 1. Okay, so we're going to ignore these values. I don't need that many because as you can see we only go up to 1. So let's do obvious values here. Let me do so at pi over, first of all at 0 we're going to be at 1. At pi over 2 we are going to be at 0. At pi we are going to be at negative 1. At 3 pi over 2 it's going to be at 0 again. And at 2 pi we're going to be at 1 again. So in between this we're going to be at 0.87 approximately here. Going to be at 0.71 here. You're going to be at 1/2 here. We're going to be at negative 1/2, at 0.71, at 0.87, and then this is going to be pretty much repeat. So this here, if I graph this, is going to give me one full cycle of that, and then it is going to continue over and over, so I can continue graphing it in the same fashion, and you are going to see a graph that looks like this, and of course on the other side it's going to continue as well. Okay, and you can continue that, that's what it's going to be. Okay, so this graph is what we call a periodic graph. It repeats once it completes a full period, which in this case is 2 pi. Right here. Okay, so full revolution around the circle is going to bring you back. Right? So this is the graph. Let's just summarize some of the things about that. So the domain of this graph is going to be negative infinity to infinity, all real numbers. The range is going to be from negative 1 to 1. It is bounded on both on top and the bottom. The function is going to be increasing. So if you look at the graph, let's just take a look at this. On this interval from negative pi to 0, it's going to be increasing. And then it's increasing again from pi to 2 pi. So we can summarize that as one possibility as negative pi plus 2 pi n. Plus 2 pi n adds a full cycle to it. So like from negative pi to 0, and then from pi to 2 pi. And then it's going to be 2 pi n, where n is an integer. It's an arbitrary integer. So just to clarify it really quick, if I make n 0, it's going to be from negative pi to 0, negative pi to 0. If I make n equals 1, it's going to be negative pi plus 2 pi, which is pi, and that's going to be 2 pi. So from negative pi to 2 pi, etc. Decreasing, it's going to decrease on this interval, for example, from 0 to pi. So I can write that as 2 pi n all the way to pi plus 2 pi n. So if you make n 0, you're going to go from that 0, that's pi, on 0 to pi. This function is decreasing, and you're going to have multiple intervals like that. It has x-intercepts at pi over 2, and then every pi from there. 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2. So it's going to have multiple x-intercepts. Pi over 2 plus pi n, be careful, 0. It's going to have y-intercept at the point 0, 1, right there. It's going to have relative maxima attained at this point, which is 0, then 2 pi, negative 2 pi, negative 4 pi, negative 4 pi. So it's going to be all together, the x values will be 2 pi, and there will be a general form for that. And it reaches a relative minimum at pi, 3 pi, 5 pi. So we can write that as pi plus 2 pi n. It is a graph that has oscillating behavior. We know that it is a sine wave. Even though it's a cosine function, we still consider that to be a sine wave or a sine curve. And we use it for many real-life applications where processes are periodic in nature, like for example waves, ocean waves, sound waves, etc. Okay, and that's it.